All right, welcome everyone. Hopefully Reinforce Day 2 is going well. This is TDR204. We will cover the session that highlights the continuous innovation in AWS detection and response services. My name is Himanshu Verma. I lead the team of our worldwide security specialists at Amazon that helps customers orchestrate AWS native security services as well as partner tools and helping them with their security journey in the cloud. And I'm joined here with Ryan Holland, who's the Senior Manager for Amazon GuardDuty. So the topics we'll cover today are an overview of AWS threat detection and monitoring services portfolio. What are some of the key enhancements that have been announced in the last recent months, as well as late as yesterday. We'll also provide a quick technical overview and demo as we go through these features. And then there'll be time for Q&A on the side. You guys can come and ask us some questions. So diving into this, all of our security services that are native to AWS are focusing on providing better visibility to our customers as you move towards continuous development and or modernizing your workloads. We want to make sure that you have the security services in place that can provide you better visibility, whether it's regards to providing detections and or providing monitoring capabilities without the operational lift of going through orchestration and or generating logs and telemetry. Additionally, what we've seen and heard from customers is that there's an increasing trend in providing that visibility to not only the security persona, but also to the developer personas. So you'll see that some of the enhancements we've been making in our services are moving towards that direction to bring the DevSecOps experience together. Before we dive into the threat detection and monitoring services, just wanted to provide you a holistic view of the breadth and depth that AWS services provide. So our goal is to provide proven security to accelerate innovation, and this is accomplished by orchestrating our services in a cybersecurity framework use case. So for instance, customers, as they increase their AWS workloads or are adding more workloads in their AWS accounts continuously, whether it's one team or multiple teams, they need the ability to identify what all controls or what all workloads are there and have a good inventory of what all security posture is being implemented so that you have good view of evaluating that security posture as well. This is where some of our management and governance tools come in that provide customers the ability to evaluate those controls and then also have visibility or continuous monitoring into whether they're following security best practices or not. Once customers have identified these workloads and inventory, then comes in the protection. So this is where some of our protection services come into play, which is protecting data at rest, in motion, in use, or protecting the infrastructure to and from AWS. So our services provide customers the layered defense that can be applied to protect these workloads. Next is the ability to detect proactively any misconfiguration, vulnerabilities, threats in your environment. So this is where most of our threat detection and incident response suite of services come in that help customers detect these threats in their environments. Most of these services will generate findings, which is what customers can leverage to orchestrate response or respond to these events. Being cloud native, these services all integrate with EventBrus or EventBridge, and then can be used to drive event-driven orchestration by integrating with Lambda and step functions, etc. And then finally is recover. So finding an incident and then recovering from that incident and making it easier and automated by leveraging disaster recovery tools or CloudFormation templates and AWS backup tools is another area where our services can help by integrating with those tools. So this is a holistic view of our breadth and depth of all the AWS security services that customers can leverage to orchestrate that in a cybersecurity framework. Now diving into the detection and response services, this is what the portfolio looks like. We're continuing to evolve this portfolio as well. You can see there are 6 security services highlighted here. So first and foremost, these services are natively integrated with AWS workloads. There are 3 detection services. Amazon GuardDuty, which is our primary service focused on identifying known threats and malicious threats or activity, and suspicious activity as well. GuardDuty brings these findings, and those findings are available in the console as well as in the event bridge to take actions on. The second service highlighted here is Amazon Macie that helps customers identify the risk posture associated with sensitive data in their S3 workloads or S3 buckets. Natively integrated with S3, it allows customers to either run on-demand scans or automatically using intelligent sampling can actually identify sensitive data that is matched to either built-in managed identifiers in the service or custom identifiers that customers can define as well. But we've enhanced the service to bring in context and risk associated with the control plane activity on the S3 buckets and objects as well. The third service is Amazon Inspector, which is our primary service focused on vulnerability management. Inspector natively integrates with EC2 instances, container registries like Elastic Container Registry, and lately with Lambda functions and Lambda code functions to detect vulnerabilities and report those as well. All these findings are then can be aggregated in AWS Security Hub, which is our centralized security monitoring, as well as security cloud posture assessment service. One of the core functions that Security Hub provides is evaluating the controls that are in your environment, which are organized in a very easy to infer security standards. So these standards are built-in aggregation of controls, such as AWS Foundational Security Best Practices and or the NIST standards or CIS benchmarks, so that customers have a high-level view of what the risk posture is. And additionally, they can dive deeper into the details of where do they need to take actions to orchestrate or configure those controls appropriately and close that gap. The fifth service that's highlighted here is Amazon Detective. Detective is a service that's mainly focused towards the security operations persona as well as the threat analyst persona. Detective helps customers investigate and identify the root cause analysis of security events. Detective is collecting a lot of telemetry in the backend automatically, not only from findings, but also the raw information, and is creating a behavioral graph that correlates all the entities, as well as is able to provide a journey map to the customer in the form of either visual interface and or going and identifying what API actions were actually taken or how did the threat manifest itself over a period of time. So Detective is collecting all that information and retaining it for at least 12 months, which provides customers and security investigators to go in and investigate those events back in time as well. And then the final service that's highlighted is to help customers organize and manage all the security data, not only related to findings, but also related to security logs. We heard from customers that this is a key challenge for them. So at reInvent last year, we announced a service, Amazon Security Lake, which is now available as of last week and has been launched. Security Lake helps customers easily centralize, organize, log data related to security use cases, not only from AWS workloads, but also non-AWS workloads as well, which means you can bring in log information from either hybrid environments or other SaaS applications or even other cloud providers. Once that information is aggregated in a customer-owned S3 lake formation bucket, it also automatically transforms all that information into a standard schema format, making it much easier for the security teams to now use the choice of their flexible analytic tools and then reduce the time that it takes to either run queries and or infer what actions need to be taken or reduce the time for incident response. So these 6 services are key to our threat detection and incident response. We will actually go into details of some of the new features that have been launched in these services, as well as showcase what these look like in the AWS console. Let's first focus on the deploying these services and how we are addressing the scale of their coverage. First and foremost, as I mentioned, all these services are natively integrated with AWS workloads. What that means is that there is no additional logging and or operationalization required. Within a few clicks, these services can be enabled both at the account level, as well as all these services are integrated with multi-account management with the AWS organizations construct. That means security teams can actually delegate a centralized management account and can easily aggregate either findings and or logs in these services, and can also manage onboarding other member accounts very easily as well, which allows customers and the security teams the ability to make sure that as new accounts are getting onboarded, these services are either automatically enabled or they have the choice to turn on off certain features within the services. So again, from an operationalization standpoint, it's very easy to enable these services, and none of these services actually require raw logging to be enabled. So just to show you a quick overview of how this looks like in the console, this is an interface for Amazon GuardDuty, where you can see I'm in the Accounts tab, and most of our services have the similar user experience where you can set up a delegated management account, a centralized delegated management account, and from there, you can see a rich option of enabling this service. Not only can you take individual actions by selecting one or many accounts and just enabling services on those, but you can also take multiple actions of auto-enabling these services either for all accounts, which means anytime you're adding new accounts, the service will be automatically enabled and will start monitoring and providing the value, or you can also do that on, for example, new accounts that are added to the organization. And in the case of GuardDuty, as we will talk more in detail, you can see the rich options that are available either at the feature level or in some cases also at the sub-feature level that you can enable and toggle these options based upon the accounts where these workloads reside, or based on how your accounts are orchestrated between dev, test, prod, etc. So this makes it very simple and easy to manage these services and enable these services across multiple member accounts, and then also aggregate their findings in one single centralized account. With that, I'm going to hand it over to Ryan to cover the first detection service.
Thank you very much, Manchu. So the first service we're going to talk about and go a little more in depth is Amazon GuardDuty. So Amazon GuardDuty's been around now for a little over 5 years. When we first launched GuardDuty, we had 3 data sources. So we had flow logs, DNS query logs, and CloudTrail events from the management side. We had later extended that to include data events for things like S3. And then most recently, we've started adding additional log sources for our EKS. So last year, we launched EKS audit log protection, and then the Aurora login events from RDS Aurora instances. And then recently we launched Lambda protection, which looks at flow logs from Lambda, as well as a runtime agent now for EKS clusters. And as Himanshu mentioned, one of the most important things is you don't have to turn on these log sources in individual accounts. So you don't have to go turn on your flow logs or turn on your EKS audit logs. When you turn on these functions within the GuardDuty service, we're automatically going to start grabbing those from the back end. So that helps save both cost in turning those logs on at scale, but also in management and making sure that they're enabled. It also has some security benefits because you can't interrupt our access to that data. So once we have this log data, the first thing we're going to do is run it through a set of different security analytics. So we look at this in different ways. We have threat intelligence-based detections. We partner with both CrowdStrike and Proofpoint. And we also get a lot of very rich threat intelligence from internal sources as well. So we partner with our internal threat intelligence group that tracks a lot of nation-state actors and a lot of other very sophisticated actors to get some good threat intel that we can apply to those data sources. And we also have a very large investment in machine learning, which allows us to baseline and do profiling of different workloads, be it a user in CloudTrail, or a bucket in S3, or an EKS cluster from EKS audit logs, and learn what is normal activity for that resource, and then raise anomalous findings when we see things that are deviating from what we consider to be normal. And then we produce findings, and the idea that for these findings, we want them to be actionable. And one of the ways that we help customers make these findings more actionable is by enriching them with a lot of context. So For an instance, that could be information about its tags or its network interfaces. From an RDS perspective, it could be, what do we normally see? Like, we're telling you that this particular login was unusual, and we now will also tell you why we found it was unusual. Like, what is the normal activity we see? Same with CloudTrail and S3. If we're going to say a user is accessing a bucket abnormally, we'll also tell you what buckets they normally access or what volume we normally see them access. And that really helps the responder to take that alert and understand why we decided to send that to them. And then all of these alerts go out to multiple different sources. So as I mentioned, you can pivot directly to detective. If you wanted to go dive deeper into an individual finding and learn more about what other activity that resource was doing, you can investigate it directly in detective from the GuardDuty console. We also send it to Security Hub for aggregation. And then we also send them out EventBridge, where a lot of customers are collecting these findings and sending them to third-party partner tools or other internally developed tools in order to do further investigation. One other good piece of enrichment we have is with our new malware protection. So for EC2-based detections, we can trigger an automated behind-the-scenes malware scan of the volume. So for example, if I tell you that an instance started doing crypto mining or contacting a C2, instead of having to go onto the instance and figure out, okay, where is the mining tool or where is the malware, we'll automatically snapshot that volume and run a malware scan against it. We partner with Bitdefender, and we also have one of our own engines that we run against this data as well. And this will allow us to send you a detection that says we found this network activity that was suspicious, and we also scanned the volume, and now here's the actual list of files that were detected as malware. That really helps speed up the response time and help the responder know exactly what they need to go look at. So I want to just go a little deeper on some of the newer features that we recently added. So I mentioned the EKS protection. This is available in two different options. So there's the audit logs, where if you turn this on, again, you don't have to change your EKS configuration. You can turn this on in accounts that don't have EKS running today, and if somebody were to decide tomorrow to start an EKS cluster, automatically we'll start getting those logs. And those go across all of the different accounts within your organization when you use that delegated admin. We're looking for things where we'll match the source IP of requests to the Kubernetes controller through threat intelligence. So coming from a malicious or a suspicious source, or like a Tor exit node, for example. And we also track configuration changes, so exposing your Kubernetes dashboard or making a role binding that allows anonymous access. Those can trigger policy findings, and then if somebody were to use a Kubernetes request from an unauthenticated source, we'll also raise alerts for that too. So it can help identify some configuration problems that could ultimately lead to someone compromising your EKS cluster. We also do some machine learning on these logs too, to understand what is normal for a particular cluster. Some of the things we look at are privilege pods, or pods that mount host level directories. There's very good reasons to do this. A lot of security tools do need access to some of those things. However, we'll learn what is normal for a pod. And if a pod comes along that we haven't previously seen request some of those elevated privileges, we can raise an alert on that to let you know that there's this new privilege pod, and if it's a malicious or if somebody were to compromise that, it would have a lot more access than you might want. The second part of EKS is the runtime protection. So we announced this at reInvent last year, and we went generally available at the end of March. And this was a collaboration between GuardDuty and EKS. So we really wanted to give customers more context to detections, but also be able to get richer and deeper detections that really can only come from the runtime environment themselves. And so we developed a eBPF-based agent. So it's a very lightweight agent that we deploy using the EKS managed add-ons. So this really helps solve one of the biggest challenges people face with agents, is getting them deployed is hard. Understanding where you even need to deploy them can be difficult. And so by working with EKS and their managed add-on, when you turn on the automatic management, if an EKS cluster comes into your environment in any account that has this enabled, we will automatically go and deploy the add-on to all of the cluster worker nodes and start collecting the telemetry. We stream the telemetry directly to a VPC endpoint that will deploy for you as well. And it allows us to move all of that detection capabilities into the back end. So that helps keep the agent itself and the resources that it needs very lightweight. And it also allows us to do more advanced detections that are looking at syscalls over time as well. So we launched over 24 new detections that are very specific to the runtime environment. Some of them are specific to container type attacks like container escapes, things like reverse shells, and then also for our threat intelligence detections. In this cases, you'll also get very rich context that I'll show you in the demo about not just that the instance or the pod performed this activity, but also which process was involved and what are the process lineage. And this really helps with responding to these types of attacks. So when you take this all together, you really get an end-to-end detection and coverage from a threat perspective for running Kubernetes on EKS. So at the control plane from CloudTrail, the interactions directly with the EKS service itself, we're monitoring all of those. The Kubernetes control plane, so those are the audit logs where we're watching how people are interfacing with the Kubernetes controller. The underlying EC2 nodes themselves, we're still monitoring the flow logs and the DNS query requests from those as well. And then the system level events that we're capturing from the runtime agents as well. So it gives you a defense in depth and across all of the different entry points for a Kubernetes environment. And then the last new extension that we made for GuardDuty, which was about in April, was Lambda protection. And so what we're doing here is we're looking at flow logs from Lambda functions and applying our threat intelligence to those flow logs. And it's important to note, again, you don't have to turn on any flow logs for these. And this works in both networking modes. So if you're using the Lambda standard network egress and you're going out our IGW, we still get access to those flow logs. And if you're going out of VPC, so you've connected VPC networking for your Lambdas and you're routing the traffic out your own IGW, we see them as well. And these flow logs are enriched with all of the function details, so you have an understanding of what was the function that was impacted and when was it last updated. So I want to show you one other thing too that we just launched yesterday, in fact, is another enhancement to the GuardDuty console itself. So one of the things that we'd heard from customers is they wanted an easier way to consume some of the findings, especially larger customers who might get a large number of findings across their accounts. So we just released a new summary page, and this again went live yesterday. It allows you to look at data over 30 days, 7 days, or 2 days, and see some trends. So how am I trending from the number of total findings or high severity findings? You can then see these findings by date and the different severities. There's a little chart that'll break down like what are the most common types of findings that you're seeing. You can also look at it by your account. So out of all the accounts that I might have, what are the ones that are generating the most findings? So this will help you kind of drill down and prioritize where you maybe want to go look initially. And then I like this one at the bottom here too, because a lot of times you might have findings that you see quite a bit. You might have something that's activity happens a lot. Sometimes it's that thing that doesn't happen very often that is most important to you, because I should never have seen Tor access within my environment, for example. So we're highlighting and bubbling up, hey, these are the least occurring findings and how often they happened. And in this case, you can see I have a set of somewhat concerning looking findings. They've only all happened once. And so you can then drill down on those as well. And then the same also will look at all of the findings you have across all of your accounts and identify what are the different resources that are generating the most findings. Again, as a responder, the things that are generating these most findings is probably something I want to go look at first, and you start to prioritize how you're going to go and address these. So we mentioned the protection plans and turning on and off the EKS protection. So I just wanted to highlight here on the cluster runtime protection. So you have the ability, again, for all of your member accounts to enable it for all new accounts, and then you can turn on just the log monitoring if you don't want runtime. And if you want runtime monitoring, you have the option of either enabling it with automatic management, and in this case, we do everything for you. So we'll create the VPC endpoints, we'll deploy the managed add-ons. Again, as new clusters come online, they'll automatically get covered. You don't have to do anything. Optionally, if you want to do it yourself, I know we have a lot of customers that like tools like CloudFormation or Terraform. You can go and manage it yourself. If you uncheck that, we'll still enable that functionality, but we won't go and create the resources for you. So I just wanted to give you a little snapshot into some of that additional context that I was mentioning from the runtime. So in this case, I have a runtime finding in one of my clusters. I executed a crypto miner, and as you can see, we get context about the cluster itself. So the cluster, its name, and then what was the workload information. So the pod level details, so you can see exactly which pod this actually ran in. And then really importantly, we also show you information about the process that did it itself. So you can see the process, its executable path, its SHA-256. So if you wanted to look at that through your own threat intelligence or look it up elsewhere. The PID, its working directory, and then also the lineage of that finding. So this can be very helpful in understanding how that process came to be, right? So you can see that the previous lineage, it was executed from a bash console. But you can imagine, for example, if I had a remote shell detection. So your process that you would see would probably be like something like NC, but if the parent process is Tomcat, for example, that would be a good signal that that vulnerability was probably a web-based vulnerability that allowed them to execute that, and that helps you go trace back where you want to go for detection. So again, we'll look at the process tree all the way back to PID1 and show you exactly how the binary or the process that created the finding came to be. The next one I wanted to show you was the Lambda detection. So as I mentioned, with Lambda now we're looking at flow logs, and a lot of times this could be something like a supply chain attack where you've got a compromised include. We've seen that before with crypto mining being embedded into Lambda functions. So looking at these flow logs, we can detect access to crypto, to C2, to Tor. And again, you're going to get all of the context that you need about the function itself. So what was the function ARN? When was that function last modified? And you can link directly to it. What IAM role the function had attached to it, which could be very useful if you're trying to investigate kind of blast radius or what that function could have access to. And then again, all the information that we have about the connection. The last one I wanted to show you was the malware protection. So as I mentioned, we can automatically trigger a malware scan for an EC2 volume. And this is both for EC2 instances, and it's also container aware. So if you're running Docker or Kubernetes or ECS on EC2, and that underlying instance generates one of the findings that is on our list to trigger an automatic scan, we will have a GuardDuty initiated scan. And we'll snapshot that volume, run a malware scan against that, and then generate a separate finding for you that details the paths, the locations of all of the malware that we found in that volume. And if you're using ECS or EKS, we'll also give you the EKS and ECS details as well. So the pod data from Kubernetes or the ECS task information if you're running ECS. All right, so after that, the next thing is to investigate findings. So with that, I'll hand it back over to Himanshu.
Thanks, Ryan. So as Ryan highlighted, GuardDuty has this rich capability of providing detections and findings, which includes a lot of contextual information. But oftentimes, customers have asked us, and especially the security analysts have asked us that, how can they correlate that information with other activities that might be occurring in the account? So for instance, who launched that instance, or what role was assumed, or what session was assumed to actually take the action, and then what other API calls were made or what actions were performed. This is something that Amazon Detective is natively collecting all the information and telemetry. So all the network activity from flow logs, all the API activity from CloudTrail, and now findings from our own security services like GuardDuty, Inspector lately, and then just last few weeks ago, we announced the ability to integrate all of Security Hub's finding into Detective as well, so that it can then bring all of that information and build that correlational behavioral graph database that customers can actually visualize within the AWS console itself as well, or leverage APIs to integrate that information. So Amazon Detective is focused on helping customers save time and effort which is required to investigate the root cause analysis of a certain event, or look at the trends as to what were the actions that a threat actor might have taken to actually launch that threat. Using machine learning model, Amazon Detective not only creates the behavioral graph database, but also creates a baseline activity of what's happening in the account. This is both related to either network activity as well as API activity. As I mentioned earlier, Detective is also collecting and retaining this information for as long as 12 months. So most of the time, security teams might want to go back in time and also view the trends for the last 45 days or 3 months, etc. So easily changing the scope time in Detective, you can actually view all that information, and then the graph updates automatically within the console. Lately, we've announced a new feature in Detective that can help aggregate these findings collectively and then highlight them either at the techniques, tactics, as well as procedures level, or at the resource level as well. As you can imagine, GuardDuty findings are automatically being ingested by Detective, so it can also highlight at the resource level not only the one finding that you might see in your incident response queue, but also all the other findings or other vulnerabilities that are potentially on that resource. So as of yesterday, there was a new announcement that was made, which is that Detective now is able to bring in information from new sources, such as Security Hub findings, as well as now supports all of our Amazon security finding format related findings, which increases the number of entities in that behavioral graph and now provides much richer context and correlation to customers. Also, over the time, we've added detections and the ability to investigate events for RDS, Lambda, and EKS runtime monitoring findings from GuardDuty in Detective as well. One of the other features that was recently announced in Detective is the finding groups and visualizations. Although customers could actually go in and traverse that behavioral graph with regards to API activity, but we've also now created a visual graph interface that provides that correlation element in a visual element so that you can reduce the time further on the correlation elements, either starting from a finding or an incident, or starting from a resource or an entity, for example, an IP address, etc. So let's switch over and see how this looks like in the console. So this is the Detective console, and on the summary page itself now we have this findings group. The findings group is actually our way of aggregating these findings automatically on the techniques, tactics, and procedures level. This is all mapped to the MITRE attack framework. So it tells you actually what were the tactics that were taken, what is the path of the all the way from initial access to exfiltration for that particular resource that is this finding group here. And then down below here is the visualization of that finding group as well. So here you can actually select one of these. The legend shows you what all this stands for. So these are GuardDuty findings, which you can start and initiate your journey from for incident response, or you can go to impacted resources like the instance to view the instance ID. But more importantly, when you go to viewing the details here, it'll show you what are the involved entities. So these involved entities could be IP address, could be instance IDs, or could be resource IDs. And we are showing you here from this IP address, we observed all these threat tactics that have been reported. So all that information is easily aggregated. Also, you can further dive and drill down into the details related to involved findings, which mean what are the known findings that have already been reported for this resource. And here you can see like I have multiple known findings already reported for this instance and from those multiple IP addresses. From here, you can actually continue to traverse your journey. If you click on one of these entities, like this instance ID, for instance, you can see when was this instance created, by who was it created, what role was assumed to do to create this instance. And then here again, we're showing you all the findings that are reported now by not only by GuardDuty, but also by other security tools that Detective integrates with, and then what are all the different findings that are related to that. And you can continue to further drill down into this by looking at things like what new behavior was observed for this instance from either geolocation or API activity. And in this case, what all Kubernetes activity, since we are bringing in the EKS information as well now with the container pods. The other thing you can do is you can easily change the scope time. As I mentioned, you can go back as long as 12 months, because once detective is enabled, it's collecting all that information and correlating that. Detective is actually one of our very few services which is natively all available from a user experience standpoint within the console. That means you can actually traverse this graph and you can look at the behavioral graph and dive down into the findings detail using the console without having to go out of the console at all. So with that, I'll hand it over to Ryan for the next detection service.
Thank you. So the next service that we're talking about is for managing vulnerabilities. So generally speaking, we think about vulnerabilities in the context of software vulnerabilities. And our service that addresses this is Amazon Inspector. So this is an automated vulnerability assessment. So it's a lot different than a traditional vulnerability assessment where you have to schedule scans and things like that. It is run automatically and it's run almost continuously. We leverage the systems manager agent in order to collect information about the packages that are on the EC2 instance. Recently, we extended that to do deep scanning. So previously, it would look at the EC2 instance and it would look at the package managers to understand what software was installed. Now we can actually go scan the volumes themselves and understand if there's other pieces of software that were installed outside of the package manager itself. It also has a direct integration with the Elastic Container Registry. So there's no agents or nothing involved to scan the ECR. If you turn on ECR scanning, we will automatically start scanning all of the ECR repos across your organization and identify vulnerabilities that are there. At reInvent last year, we announced support for AWS Lambda as well. So Lambda, especially with Lambda layers, we could already scan some of the packages if they were in ECR repos. But with the standard scanning now, we can also scan the code that you push up into the function itself. So what we had launched last year at reInvent was the standard scanning. So we're looking at the package dependencies that are within the function's code definition, looking for CVEs. What we announced yesterday at our keynote was the code scanning. So this is really cool. It's an integration we worked with Code Guru on to actually scan the source code itself and look for vulnerabilities like injection flaws or data leaks, weak cryptography, other best practice misses that can be identified in the source code to raise findings about that aren't necessarily package vulnerabilities. It's more a software development vulnerability. And for both of these, it happens again automatically. So once this is turned on, we scan all of your functions. If somebody updates the function or creates a new function, they're automatically scanned at that time as well. So these have to be enabled, and again, like with GuardDuty, as we were showing you, you have the ability to manage all of these features and functionality, not just for a single account, but across your organization. And for Lambda, you can choose whether or not you want just the package level scanning, the standard scanning, or if you want us to do the code level scanning as well. And again, you can do that at the organization level or on individual accounts as well. So I'll show you the findings in the console here in a minute and with more detail, but as you can see, you get a lot of context about these findings. What is the package? What is the required update in order to fix that vulnerability? And then the other ones that are really important is exploit availability. So this really helps when it comes to looking at prioritizing which vulnerabilities maybe you want to start with, right? There can often be more work to do than you have time to complete, especially when it comes to vulnerability management. So we try to help give you clues as to which ones you might want to prioritize. And then the code scanning, as you can see over there as well, will show you the exact line of code that needs to be addressed and a recommended suggested fix for that line of code. So it really helps identify these vulnerabilities in your code. The other thing that we launched for Inspector yesterday is the software bill of materials. So we're scanning all of your instances, we're scanning all of your Lambda functions and your ECR repos. We're looking for vulnerabilities, but we can also then collect very rich information about what you have installed across your entire compute landscape. And this can be very useful if you suddenly wanted to know, hey, do we have a particular version of a piece of software running anywhere in my environment? Well, software bill of materials will help you do that. We support two of the most common industry-supported formats, so Cyclone DX and SPDX. This is a free service, so you export this directly to S3. It'll put in S3 bucket, and then you can run Athena queries. You can use QuickSight to visualize it. You can run your own tools against the data if you wish as well. And this, again, will help you understand exactly what software you have, and if there's any vulnerabilities identified for those packages, we'll include that as well in the bill of materials that gets written out to. I'll just show you what some of that looks like here. So again, on the inspector console, we have a summary page that gives you at first an understanding of how your environment is coverage looks. So how many of your accounts have it enabled, how many instances you don't have the inspector reporting on. So like if you don't have the SSM agent active, then you'll have instances that aren't covered. Same for your ECR repositories and Lambda functions. We highlight what your most critical findings are up top. So again, give you a way to help prioritize and put focus where you need to start first. Then we do some risk-based remediation. So these are vulnerabilities that are impacting lots of different resources within your environment and are either high or critical from a vulnerability standpoint. Again, just to help focus people on where you might want to start. And then again, we'll show you the top findings by ECR repo, by instances, by AMIs. So if you're using common images across your environment and you're using auto-scaling, for example, you might have a large number of instances that have the same vulnerability, but its path to fixing that is probably in an image somewhere. So you go, knowing which AMIs you might want to go update and respin is a very useful way of tackling those. And then again, for your Lambda functions, so I'll take a look at a couple of these here. So I can look at these Lambda functions, and you can see the vulnerability that's on there. And again, we'll tell you whether or not there's a fix for it, and also if we've seen it being exploited in the wild, and also when the last time we saw it publicly being exploited. Again, all very useful for understanding what it is, which of the vulnerabilities you might want to go address in your environment first, and then the remediation step. So what version do you need to run versus what version are you running in order to be not vulnerable anymore? Links to external data sources for the CVE itself, and then all of the information that you need about that function. So the context of where that lives, what account it lives in, what the function arn is, the runtime that was used, so what type of code, that's Python, for example, and then any of the tag data that's associated with it. And then similarly on the code scanning, as I mentioned, this is where we're gonna look at the actual source code that's uploaded into the Lambda function, show you what was found. So this was a CWE. And in this case, I'm binding a socket to any IP address, right? So that means basically anyone can come along and it will accept a connection from that. And then it gives you the recommendation on how you should go about fixing that, highlighting the exact line of code where that particular software vulnerability was identified. And then again, all the context about the function itself.
From these detection services, you can see that as the findings are generated, once they're available in the console, they're also available through the event bridge, event bus queue to orchestrate them and aggregate them in downstream automation. More importantly, they all are aggregated in Security Hub. So Security Hub is our centralized monitoring service that is bringing in findings from native AWS security services, as well as partner integrated tools. So you can actually have one place to aggregate all these findings. Additionally, Security Hub normalizes these findings into Amazon Security Finding format, which, as I mentioned earlier, then Detective leverages to correlate that information easily as well. More importantly, what Security Hub is doing is helping customers stay secure by providing an overarching view of controls that are being evaluated. So Security Hub uses, at the foundation, AWS Config Recorder to continuously monitor new workloads, new controls that are implemented automatically, and then help customers understand that risk or evaluate those controls on built-in standards. So some of the standards that are already available in the service are things like the AWS Foundational Security Best Practices, which is our collection of these controls, telling customers where they can go and address some of the security gaps. Additionally, we've also launched a NIST standard now that's available based on customer feedback. And then the CIS benchmarks have been updated to the latest version based on the new controls and definitions. Additionally, Security Hub also integrates with Control Tower, which is our governance and baselining service that helps customers define now either preventative or detective controls. So those evaluations and those findings can also be integrated into Security Hub. Using all these findings, customers can then automatically orchestrate operations That could be either as simple as defining workflows for ticketing and or using chat-based operations, sending it to the incident response teams, and taking event-based actions by integrating them with either step functions or lambdas, or defining custom CloudWatch actions that can then take collective response actions as well. Customers, and we have published a GitHub library of these runbooks and playbooks that actually customers can easily import and also add them to the workflow within Security Hub's interface to take those actions. Most recently, we've added a new feature that was just announced yesterday, which is the automation rules in Security Hub as well. Oftentimes, customers will receive findings which they would want to go and change the attributes on conditions on before they are routed downstream for taking actions. So that's where now Security Hub allows customers to create those automation rules as well, and then they can also see the history of what changed in those findings. So Security Hub is essentially focused on providing not only that risk view, but also helping customers to orchestrate a response and remediation across their full AWS workload. And then it allows customers to either leverage custom CloudWatch actions for that automated response, or leverage built-in native partner integrations to either SIEM and or SOAR platforms or XDR platforms where you can send these findings. And this is, again, to help customers easily integrate with existing workflows so that you can enable the incident response teams. Going back to the console here for Security Hub, on the summary page of Security Hub, you can see all the standards that are enabled, and then a high-level aggregated view of the risk posture across those standards. Additionally, we'll give you more information around what regions these findings are getting aggregated from. Security Hub is actually one of our other services where not only are we bringing information from multiple accounts, but also multiple regions as well. So since AWS Organizations is a regional construct, we've enabled a cross-regional aggregation of these findings so that there's one place to view that across all regions as well. Additionally, customers can create insights which could be useful for their security teams based on either a resource type or based on a workload type. From here, you can either dive into controls or go into a specific standard, and you can view what are all the different findings and what exactly are the controls that are evaluated as passed or fail. These are all automatically ordered in the order of severity. So from here, you can see, I have a user, a root user who does not have MFA, again, a critical finding. And then you can actually dive into these findings from here based on either filter them by resource. So if you just want to look at your failed findings, and from here dive deeper in, you can actually click in on this finding as well and look at what are the controls that were failing. And then from here, you can dive into the finding itself as well. Also, all the findings are available in one single view here as well. So you can see here the finding detail. These are all organized in the Amazon Security Finding format. And most recently, we've actually included a feature where you can not only see the details of the finding, but you can also view the history of the finding as well, which is how has this finding manifested itself, and then what are the changes that have been happening. So here you can actually see one of the new features that was announced yesterday, which is automation rules. This finding has been changed and edited or evaluated by that automation rule. So automation rules is a way of helping customers define their own custom actions that they want to take on these attributes before these findings are then either sent to the incident response team and or downstream tools. So things like changing the severity of the finding based on a certain either product that it came from or the resource that it came from, or elevating that finding, and also enriching that finding with security-defined information. So here you can see what was the rule that was defined, giving it a name to enrich that finding, and then also the criteria that was used, in this case, the product name, and then what automated action is being used, in this case to be tagged so that once it's received by the incident response team, they have this additional enrichment that they can use. So these automation rules should help customers define or add more context to these findings before they're sent to the. Moving forward, we wanted to also help customers centralize the management of security data for all your workloads across your enterprise. So not only just AWS workloads, and not only just findings, but also the log information, which is often required by the security teams. So last year at reInvent, we announced a service, Amazon Security Lake, which is now generally available as of last week. Security Lake helps customers centralize all the log information, not only from AWS native logs and workloads, but also non-AWS logs, either from on-premise applications or SaaS applications or other cloud providers as well. Easily aggregate that and centralize that and optimize all that information in a standard format called the Open Cybersecurity Schema Framework. That's an initiative that Amazon actually partnered with industry leaders, and then it's an open standard schema, or our way of democratizing the finding format for all the tools that are generating findings. Once it's normalized, then it's available for analysis that customers can integrate with multiple different analytic tools. So whether it's a SIM tool that you might be using or a SOAR tool. One of the common objections we heard from customers was that they often didn't have control over their security data to either enrich that, or they were spending too much cost on either ingress or egress of that data to other tools. So the way this service works is that at the center of it, once it's enabled at the account level, it can automatically create a centralized S3 lake formation bucket. It can also be can be integrated with AWS organizations for centralized management and aggregation across multiple accounts. And automatically, the AWS log sources that are today integrated are all the API activity from CloudTrail, network activity from flow logs, and also data plane events from S3 and Lambda, and the security findings from Security Hub. So all that information is actually automatically integrated, which means customers do not have to go and exclusively enable any of these log sources. In addition to that, our partners and other solution providers have built integrations that can bring in their log information as well. So whether it's from endpoint telemetry, or whether it's from SaaS applications like firewall, gateway providers, and or identity providers, etc., all that log information can also be integrated into that centralized S3 lake formation bucket. And then we also have options for customers to add their own custom sources. So either you might have existing data that your security team is using, or in the future you might want to bring in not only your corporate workforce data, but consumer logs as well. So there are options to bring in that data as well. For the AWS log sources, we will automatically normalize that into OCSF, and then our partners are integrating and providing integrations to bring in their logs in OCSF format as well. Also, in the center of the service, you can actually set up the lifecycle management, which means you can define what you want to do with that data and who should use that data and how they should use it. For example, security teams might need 30 days worth of data or 3 months worth of data for active analytics. So you can keep that in hot storage, and the rest can be stored for longer term retention in cold storage. So those are configurations that you can define easily. All the data is then automatically standardized schema as well as directory structure. So you can actually go in and per region or per account traverse the data all the way down to the Parquet objects, which is automatically done. So as I mentioned, once you enable the service in your account, we do all the operationalization in the backend so that you don't have to create multiple S3 buckets and you don't have to run glue tables or lambdas. That is all automatically done, and the information from the AWS logs is brought automatically in. What you see on the right-hand side is the flexibility of what you can do with that data. There are two ways that data can be accessed. The first one is direct S3 access, where you can stream S3 objects to an integrated tool. Or the second one is in-place query access, which means you don't have to move the data anywhere. Because we are supporting virtual indexing and virtual querying in the service, you can actually query the data from where it is as well. So using native AWS analytic tools like Athena, you can actually run standard SQL queries because all the data is now transformed in a standard schema. So you're no longer writing complex queries to look for IP address, for example, which might be different in format for AWS logs versus a firewall log. All of that is automatically normalized and ETL'd into OCSF. That helps reduce query times, that helps reduce the time to respond, and create much more richer analytics downstream. Also, customers can leverage tools like OpenSearch, QuickSights, Kibana, et cetera, to build their own custom dashboards and use native integrations with tools like Splunk or QRadar, et cetera. So there's a list of variety of partners that are already available both as sources as well as subscribers in the service. So we hope customers will leverage this service to orchestrate and easily manage all the data that's needed for security analytics. And this will actually give them control of their data as well as easily allow to aggregate and centralize that data for their security teams. So to summarize, all of our security services are here to help customers protect their workloads. One of the key aspects of protection is to first be able to detect some of the elements. So security tools that are natively available in AWS are integrated with AWS workloads that eliminate the need of any operationalization. It also helps reduce the burden from the security team by allowing them to easily centrally manage all these security services, easily enable these services as well. And then finally, to allow for scale and then centralized management of security data, we now have a service that can allow customers to do that as well. Like I said, most of these services can be deployed at a single click, so there's no additional log enablement or operationalization required. So with that, thanks for your time and thanks for joining. Please take the session survey and appreciate you joining us today. Thank you.